In this video, we present our multi-platform attestation verification solution developed at Ericsson, Finland. This solution performs verification of attestation evidence from multiple TE platforms via portable WebAssembly components. The problem we are addressing is that the verifier that assesses the trustworthiness of trusted execution environments needs to be able to interpret attestation evidence from a variety of different platforms, which use, for example, their own evidence formats, signatures, and key distribution models. As a solution to this, we encapsulate platform-specific verification functionality within WebAssembly components that have a common platform-agnostic interface. The solution is developed in Elastic Work Package 3, and in the Elastic architecture overall, it's related to trust and access control, primarily attestation and verification functionality. Our verification components in this solution are dynamically loadable, so when a verifier encounters a new type of TE, it can download and instantiate a corresponding component on demand. The components share a common platform-agnostic interface based on WebAssembly interface types, and thanks to WebAssembly, the components are portable and sandboxed. The components are signed by a trust party that can be provided by an attester alongside its evidence, and then used by a verifier such as a TE attestation service. The components can leverage WASI interfaces for fetching endorsements, reference values, and other inputs needed for verification of evidence. For example, the WASI HTTP interface can be used for acquiring keys, revocation lists, platform-specific values, or other needed information. The verifier can use capability-based security for controlling the component's access to such interfaces. We have currently implemented components for AMD SEV-SNP and Intel TDX evidence verification. These components perform evaluation of evidence signatures and platform-specific values. In addition, we have also extended the trustee attestation service with the ability to dynamically get verifier components via an HTTP API and instantiate them in the Wasm time runtime so that trustee can use these components instead of just its built-in verifier drivers. After this initial verification step, trustee can proceed to perform additional platform-agnostic verification operations such as policy checks. Next, we will show a demo of our solution. In the demo, we will use the attestation service for verifying evidence from a SEV-SNP-based virtual machine with a corresponding component, and then repeat this with evidence from an Intel TDX-based Azure virtual machine. We start the attestation service, shown in the terminal to the left. On the right, we then run a password-like attestation procedure for SEV-SNP evidence. We submit the evidence for the SEV-SNP virtual machine embedded in an attestation request in JSON format, along with a corresponding verifier component to the service. The service checks the component signature and instantiates it. The attestation service then uses the verification component to evaluate the evidence, which in this example is done using a corresponding endorsement key and a cached certificate chain for the key. The service produces an attestation result, which the attester could send to a relying party. We do a similar attestation procedure for Intel TDX. So we submit the evidence along with the component and the verifier instantiated. In this case, the verifier fetches the collateral needed for verification and performs the evaluation of the evidence. Again, it emits a result that the attester could send to the relying party. This solution is also being integrated to the Work Package 5 IoT Data Fabric demonstrator for smart connected factories of the future, where it has a role in enabling secure data handling across platforms. As part of the attestation flows in this context, we are addressing delivery of verification components alongside evidence to verifiers. And on the attester side, we plan to use our solution in conjunction with a common hardware abstraction layer that supports acquiring attestation evidence from a platform. Finally, we also plan to implement verifier components for one or more additional hardware platforms. This concludes the presentation about the multi-platform attestation verification solution. Thank you for listening.